All right, let's talk about electrons. So they call this life on the edge because electrons are sort of like the skin on your body. They're the outside of the atom. So why do we care about electrons and where they live? Because that's really what we're talking about in this lecture. We care about electrons because it tells us a lot about the atom's properties. It helps predict the reactivity of the atom, the types of bonds that it will form with other atoms, and the number of bonds that it will form with other atoms. So let's discuss core versus valence electrons. You may have heard the term valence electrons before. As a refresher, those are the electrons on the outermost shell of an atom. And the core electrons are all the other atoms that are found inside the outermost shell. So let's look at this example. How many valence electrons does aluminum have? 1, 2, 3. How many core electrons does aluminum have? So it's all the rest. So 2, 4, 6, 8, 9, 10. And aluminum is number 13, so it makes sense that a neutral aluminum atom will have 13 electrons. There are 7 shells where electrons are found in their ground state, depending on how large the atom is. But there are actually an infinite number of shells that electrons can get excited and jump to. So the labeling starts from the inside, the first shell, and it moves its way out. So the shells are the regions around the nucleus where an electron is likely to be found. And the shells get higher in energy as you move further away from the nucleus. So this is sort of like a ladder. You cannot stand between rungs. Like if you're climbing a ladder, your foot has to go on a rung in order to move up. Electrons can only live in the shells, so they cannot live in between shells. They're at fixed distances from the nucleus. And the lowest rung of the ladder is the lowest in energy, so the shell that's closest to the nucleus. And then you can imagine as you're trying to stand up on the top of the ladder, you're really unstable, and that is the highest energy. How do you know how many energy levels, aka shells, an element will have electrons in? You look at its period number. So for example, hydrogen has just 1 electron in the first shell because it's in row number 1. Same with helium. It only has electrons in the first shell. All of these atoms have electrons in the first shell and the second shell. And so on and so forth. How many energy levels or shells would magnesium have electrons in? Here's magnesium. It's in group 3. It's in period 3. So it would have 3 shells. And we can count them. 1, 2, 3. How many shells would each of the following elements have electrons in? I want you to pause the video and use the periodic table off to the side to look at the period number that each of these atoms is in and figure out how many shells would they have electrons in. Okay, let's check your answers. Helium is in period 1, so 1 shell. Chlorine is in period 3, so 3 shells. Oxygen is in period 2, so 2 shells. And lead is in period 6, so 6 shells. How can you tell how many valence electrons? Remember, those are the electrons in the outermost shell a main group element has. Answer, it's the same as the group number. So all of these are in group 1A. They all have 1 valence electron. All of these atoms right here, the alkaline earth metals, all have 2 electrons in their outermost shell. All of these have 3 electrons in their outermost shell. All of these have 4. All of these have 5 electrons in their outermost shell, 6, 7, and 8, but it starts at neon and down because helium's just a little guy, so it has only 2 valence electrons. So how many valence electrons does magnesium have? It's in group 2A, so it should have 2. And we can count them, 1, 2 electrons in its outermost shell. All right, your turn. How many valence electrons would each of these elements have? Remember, helium was a trick question, so I'm going to put that one up there. Even though it's in group A, it only has 2 electrons. So pause the video and complete the rest. All right. Chlorine's in group 7A, so it would have 7 valence electrons. Oxygen is in group 6A, so it has 6. Lead is in group 4A, so it would have 4 valence electrons. So how do you figure out the number of core electrons? Well, it's everything else left over. So we know the total number of electrons because that's the same as the atomic number in a neutral atom. So if you know that, then subtract the number of valence electrons to get the number of core electrons. So how many core electrons does magnesium have? I should tell you too that magnesium's number 12. This one annoyingly doesn't have it. So you would do 12 minus the 2 valence electrons, and that would be 10 core electrons. So we can count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 core electrons. All right, you try. How many core electrons would each of the following elements have? I want to give you the answer to the first one. Because helium only has 1 shell, it doesn't have any core electrons because it only has a valence shell. But you should be able to do the rest of these. So pause the video and then take a second and work on these on your own. So chlorine, it's number 17, and it's in group 7A. So you do 17 minus 7. There's 10 electrons in the core. Oxygen is in group 6A. It has 8 total electrons, so 8 minus 6 is 2. Lead is in group 4A, and it's number 82. So you do 82 minus 4, 78 core electrons. The atomic radius of an atom is half the distance of one nucleus to another. Another way of saying that is just like the radius of a circle. It's the center of the circle to the outermost edge. Fun fact, it's so tiny that it's represented in picometers, 10 to the negative 12th meters, 1 trillionth of a meter. So here is a hydrogen atom, 1 proton, 1 electron, and a helium atom, 2 protons, 2 electrons. They both just have 1 shell. Which one do you think is going to have a larger atomic radius? Answer: the hydrogen atom is actually larger. If we go back and look at this picture, this has 2 positive protons that are attracting these electrons in, whereas hydrogen only has 1 positive proton that's attracting that shell, that 1 electron in that case. So helium, because of that tighter pull, will actually have a smaller radius. And this is just showing you here they have 37 and helium 31. So the atomic radius gets smaller as you go from left to right on the periodic table. Another way of saying this is when the number of shells is the same, in this case it was 1 shell, the more protons in the nucleus, The higher electrical force pulls electrons closer to the nucleus. All right, so let's test you out. Draw the following atoms and determine the order of their increasing atomic radii. So I want you to list them from smallest to largest. So the atoms that you're going to build are lithium, oxygen, neon, and sodium. So most are in period 2, and one is in period 3. And so by building these, I really mean draw. So lithium is number 3, so it should have 3 positive protons, and it should have 2 shells of electrons, 1 electron in its outermost shell, and 2 electrons in the core. And it also has 4 neutrons. So this is a good review of everything that we've done so far. So take the time right now to pause and try to draw each of these and figure out which would be the smallest and which would be the biggest. All right, I'm going to reveal the answer. Neon was the smallest, then oxygen, then lithium, and sodium is the largest. So how do we make sense of that? So I built these with little dots, and I drew rings on the table. So let's start with the smallest. Neon only has 2 shells of electrons, and it has the most positive protons in the middle. It's got, the red ones are the protons, it's got 10 protons, pulling in 2 shells. Oxygen only has 8 protons, pulling in 2 shells, so it's a little bit bigger. Lithium only has 3 protons pulling in those shells, so it cannot hold them as tightly or attract them as tightly, so it's larger. But sodium's the biggest because it's got 3 shells, whereas these all have 2. Below is a model of a hydrogen atom and a lithium atom. Which one do you think has a larger radius? Well, lithium has 2 shells. Hydrogen only has 1. So just like we saw in the last problem, that should help you out if you want to pause the video before I put the answer up. The lithium atom is larger. Valence electrons are at higher energy levels. They're not bound as tightly to the nucleus because they're shielded by other electrons. This is called the shielding effect, where because electrons repel each other, the more shells you start getting, the further out the electrons are and the larger the atomic radii. Another related concept that you might hear come up is called ionization energy. That's the energy needed to remove an electron from a gaseous atom. So there's something called the first ionization energy. How hard is it to remove the first electron? And the second ionization energy is energy required to remove a second electron. So the more energy required, the harder it is because those protons are holding those electrons close. All right, make a guess. Do you think it would be harder and take more energy to take an electron away from a lithium atom or an oxygen atom? Hint, which one's holding its electrons more tightly? Okay, pause and write down your idea. Question number 2, do you think it would require more energy to take an electron from a lithium atom or a sodium atom? These are in different periods. Lithium's in period 2 and sodium is in period 3. So pause video, make your guess. For the first question, if you said oxygen is harder to take an electron from, you're right. It's got more positive protons in the nucleus. And so it's going to be watching over, so to speak, those electrons more closely. It's attracting those electrons to the nucleus. Do you think it would require more energy to take an electron from lithium or sodium? It's Harder to take it from lithium because lithium's smaller. So the electrons are closer to the nucleus, and that means it takes more energy to remove them. And that is it for all about electrons.